All right, folks. I'm going to do a couple problems on the integral test here. This is from my notes. I'm going to do example one, which is, or say, actually, it's example two of the series to determine the convergence of this series. Now, I believe that we know that this is okay, so 1/4, 1/9, excuse me, 1/16. Okay, we haven't seen that as often as the others, but what we do know is that this is a p-series. So just from our other knowledge, this is a p-series with p greater than 1. So we know that this converges. But what we're kind of interested in today is the integral test. So integral test says that says that a particular series will converge if essentially the integral of it converges. So it says this will converge if the integral from 1 to infinity, think about this as since this one is 1 to infinity, the integral from 1 to infinity, now you take this and you basically make the function where x is wherever you see the n. So it says, hey, this guy will converge if this integral converges. And what we mean by that is just, is the integral a finite number? So the reason I'm making a video on this is because it has a couple ideas that we really haven't seen yet. First of all, the idea that we haven't seen yet is an infinity in the bounds. The way we work around this is that we say, hey, we're going to change this to a limit as b goes to infinity, like that. This is kind of our workaround, okay? Because we don't know how to really, I mean, there's some shortcuts and stuff, but we don't know how to integrate when there's an infinity in the bound. So what we do is we'll say, well, we'll just do 1 to a number, which we do know how to do, but we'll limit that number to infinity. So this will get us to the same thing. Now let's go ahead and put this x to the -2 right there, dx, if anybody particularly needs it. All right, so limit as b approaches infinity. And let's go ahead and integrate this. So you add 1, and then you divide by your new exponent. Okay. So what we have is a lot of negatives. 1/-1 is just negative, and x to the -1 is 1/x. So let's take some time and simplify those negatives like that, okay? It's very important. Then the limit is ready to do something almost. So it says it's the limit. So remember, it was the limit of this integral. So it was the limit of, and then we put this b in here, and then we subtract, and we put a 1 in there. Now remember, it's subtract a negative, and then we have limit as b goes to infinity. Let's clean this up a little bit. -1/b plus 1. Okay. So we have just come from a couple sections of limits, of sequences and stuff like that. So I think we're pretty confident that as b goes to infinity, this piece here is going to go to 0. So this whole limit equals 1. It equals the number 1. And it's not exactly, we're not too concerned about the value itself, about one. We're not super concerned about it being one. What we're concerned about is that it is finite. That's what we're concerned about, because that's essentially saying we took this sequence, right? I'll draw you a little quick picture here. We say, hey, this sequence, it starts off as one, then it's 1/4, then it's 1/9, then it's 1/16. And basically we created a function and then we integrated that and said, hey, the integral of that was finite. So if the integral of that is finite, then if you would, and that's basically adding up all this area, that is somewhat related to adding up the sequence. If you just add up the sequence, then that should also be finite. So the integral test says because this integral right here, because this integral is finite, then this is finite. By the kind of using some of the logic there. So final answer, according to this integral test, is that this right here converges. Now, does it converge to one? No, that's not how this works. The integral test just tells you what this, whether this converges or not. It does not tell you what it converges to.